Hello everybody, Mr. Ligon here. We're going to be talking about equivalent fractions today, how we can find them, and just kind of help you understand more about what they mean. They're very, very helpful for us when we are going to add and subtract fractions, and when we have to simplify later on when we're multiplying or dividing. So I'll start by asking you a question. Let's say that I had some cake left, and I asked you to choose between eating half of the cake, 2/4 of the cake, 4/8 of the cake, or 8/16 of the cake. How much of the cake would you choose? Now, a lot of people might choose 1/2 because it's half of a cake. It's easy for us to understand. Fewer people might go towards 8/16 of the cake. But if I had to have you choose, the correct choosing would actually be all 4. Yep, that's right. All 4 fractions of cake are actually the exact same amount. As you can see here, we have 1/2. Here we have 2/4. Here we have 4/8. And here is 8/16. Now, if you don't believe me, I'll do a little trick here. If we take each of these and set them on top of one another, you will see that the blue portion is exactly identical in each one. So, if we were to say that half of this cake has blue icing, the other half has gray, what we mean by that is no matter how many pieces there are, half of the cake still has icing. It just so happens that we've cut the pieces into different parts. So in this first cake, there are 2 pieces, and one of those parts is blue. In the second piece, there are 4 total pieces, and 2 of those parts are blue. In the third cake, we have 8 total pieces, and 4 of them are blue. And in the last cake, there are 16 pieces, and 8 of them are blue. There's still the same amount of cake in each one that's blue, but they're cut into different sized pieces. Now, it might be kind of easier to show you if I actually make these equivalent fractions with the picture here. So right here, what we have so far is we have the fraction that is 1/2. So we have 1/2. Now, if I make a slight adjustment to it, I'm going to cut it into that many pieces. So no longer do I have 1/2. I now have 2/4. Now, it is important to actually understand what the numbers in a fraction mean, the top number and the bottom number. So we're going to use this model here of 1/2. So if I look at this whole model, I have 2 total parts. That's the number that goes in the bottom. It shows me how many total parts I have here. Now, if I'm looking at the part that's shaded blue, I have 1 part. So one of the 2 parts is shaded blue. And now each of these numbers have a very important name that you have to know. The bottom number is called the denominator, and the top number is called the numerator. The numerator represents the number of pieces you're trying to show, or the number of pieces you have, the number of pieces you're trying to represent, and in this case it's 1. The denominator tells you the entire amount of possible pieces that you have, and in this fraction there are 2. Now let's say we want to change that up, and we have company coming, we have a couple more people I gotta share my cake with, so I'm going to slice it up into different parts. So my numerator and my denominator are going to change. So I no longer have 1 blue part and 2 total parts. I now have 4 total parts with 2 of them shaded blue. So my numerator is now 2 and my denominator is now 4. However, the amount of the model, or of this cake in this case, that was blue to begin with, is the same amount that's blue now. It's important to know that as the denominator goes higher, as this number gets larger, the pieces are actually getting smaller. So, before my denominator was 2, but I had 2 large pieces. If I look at this, so 2 large pieces. but now I've cut it into 4 total parts and the pieces are much smaller. Alright, the very last thing that I'm going to show you very quickly is how you can find equivalent fractions. So let's just say we have 1/3, okay, and I need to find an equivalent fraction for that. What I will do is I will multiply the numerator and the denominator by the same number. That will increase the number of pieces that I have total and increase the number of total possible parts that I'm trying to represent. However, the fraction itself is still the same. It's still equal. So let's just say I'm going to find an equivalent fraction of 1/3 and I want my denominator to be 6. So I'm going to multiply the top and the bottom by 2. Multiply straight across, I have 2/6. So 2/6 is the exact same as 1/3 as far as the size of the fraction. In 1/3, I have a fraction that has 3 total pieces with the 1 part I'm trying to show or represent. In 2/6, I have 6 total pieces with 2 that I'm trying to show or represent. But the fractions themselves are equivalent. Well, I hope this video helped a little bit with your understanding of equivalent fractions and kind of what they mean. Don't forget to like and subscribe if you haven't already so that you are notified of any future videos that I come out with. And my next one should be coming out shortly for addition and subtraction of fractions, so keep an eye out for it. See you later.